includes a config file. LFTP comes to mind, the main lftp.conf file. So notice this query for LFTP returns that LFTP relies upon etc lftp.conf for system-wide settings that are defined whenever a user by default enters LFTP. And similarly, the other queries would work that we've performed against grep for LFTP. So here are the documents for LFTP. LFTP, get, there's even a documentation file for the config file so that you can learn more about the configuration directives, and a top-level container beneath user shared doc. You'll find documentation for most, if not all, of the packages on your system beneath user shared doc and the name of the package. But the D option will reveal that to you. So this time we've referenced LFTP because it actually contains a config file. And in our case, it returns that the config file is in etc. So we've been querying packages that are installed on the system, but we should also note that you may also query packages that are not installed. Certainly, we have not installed all of the packages included with the tree that is on our server. So supposing you are contemplating installing additional packages, but would like to learn more about those packages prior to installation, RPM will also help you out. But whenever you query a package via its file name, whether via URI such as HTTP or the file system, you need to use the P option to indicate that you're querying the package directly, the binary directly. And then the rest is status quo. So if you want information about a package that we've yet to install, let's say Unix to DOS, which we tend to always install, then get the full name for Unix to DOS and then pass it to the query package info option. So to get that full name, let's navigate to the server, and we still have this up, so we can Control F here and search for Unix to DOS. And if we copy the URL and paste it into our RPM search string, this will cause RPM to use HTTP as a source for referencing the binary. But notice that in this case we specify the P option after the query option. So we enter the query mode and then the P submode to indicate that what we're querying is not in the database, but is actually on a file system somewhere, perhaps locally or across HTTP. So let's go ahead and query this URL. And it uses HTTP. If you had TCP dump running, you would see, for example, the query out to the remote system. And there is the information about Unix to DOS, its name, its version, its release, and the other fields that we've discussed. And similarly, other information may be returned about this remote package. So query package info, perhaps we'd like to query package list. Let's try to list the items that are included with Unix to DOS. This is a package that doesn't contain too many items. It includes a binary and documentation directory and a man page. So before we've installed the package, we are able to interrogate it to learn more about it. And we know that this package isn't currently installed. If we do which Unix to DOS, nothing comes up. And if we do an RPM query all grep Unix to DOS, for example, it doesn't come up. And in this case, we need to include the hyphen, and it won't come up. And no matter what we try, it will not come up because it's currently not installed. So we can query all, we can query the package by extracting its unique name, which would be Unix to DOS before all the version information. In fact, the info told us that, so if we query this locally, we'd expect to find information. Let's query info, and it's not installed. But it is across the wire on our HTTP repository. So that's a little bit about the query option. Let's move on, or mode. Let's move on to verification. So verification, or verify mode. This mode verifies packages or the contents of the file system. So verifies file system contents against installed packages, or package, because it's done one at a time in RPMDB. And it returns when we instruct it to test for discrepancies let's just note that it returns a single dot per test performed if the test has passed. So returns dot per test performed if the test pass. And if the test has failed, then a particular value is returned, and there are a number of those values. So note, if test fails, one of the following will be returned. So a number of tests are performed. If you see, for example, instead of a dot, the number 5, it means that the MD5 signature failed. If you see an S, it means that there's a discrepancy in the file size. If you see an L, there's a symlink error. If you see T, for example, there's a modification time discrepancy. If there's an uppercase D, there's a device problem, such as wrong device name, missing device. If you see an M, uppercase, there's a mode issue, which can relate to permissions, or the mode of the file. If you see a question mark, RPM was unable to read the file. And if you see an uppercase U, there's a discrepancy with the user owner. And similarly, an uppercase G means there's a discrepancy with the group owner. These are the types of tests that are performed when you perform a verification on a particular package. So how does verification work? Let's show you how this would work. Supposing we wanted to verify bin grep. So we'd execute RPM, uppercase V for verification mode, and lowercase v for verbosity to print information to us on the file, F means file, bin grep. This will compare the bin grep binary, or grep binary in the bin directory, against the metadata stored in the RPM database concerning that file. So let's go ahead and try this out. And now as we scroll up, all of these items are items that are contained within the grep package. For each item tested, notice all of the dots. That means, since we see none of the other values that we've mentioned, that all of the tests have passed for all of these items, which means there are no discrepancies between the file system representation and the database representation of the contents of the grep package. These items here just happen to be beneath a particular directory, which is why the directory is referenced in that particular case. It's a file within it. So how can we introduce a discrepancy to prove whether or not RPM is doing its job? Well, that's quite simple. So let's just note, compares bin grep to grep RPM. So to introduce a discrepancy, let's move, or perhaps even copy, let's move it to a new file, then create a new dummy file. So we'll move bin grep to bin grep.original. We'll restore it when we're done. And then we'll touch bin grep, which will create a 0-byte file, which will certainly cause a discrepancy. And any process that relies upon grep will fail for that particular point, so don't do this on a production system. Let's SU in. We need to be the root user in order to effect this change. So if this has run successfully in bin, we now have two instances of grep, a 0-byte version and the original. Now let's rerun our verification. We should just copy that, or we can just RPM verify the file, and we want verbose information on the file bin grep. Now most of the files will return well, but as we scroll up towards the top, we'll see that there are discrepancies in the file bin grep. So if we compare what we see here to the fields that we've outlined, no need to memorize them, or if you just consult the RPM documentation, you'll see what each of the values mean. But looking at this, we see, for example, that the S test failed. That means the file size of bin grep is incorrect, which means if we use DD or some other means to make the size correct, then the file size, meaning the actual size of grep, would be okay. But beyond the file size, the MD5, or in this case, the mode has failed, not the MD5. The next step is the MD5 has failed. So M, the mode has failed. So there's a discrepancy between the mode. Now let's compare and contrast, just to be clear. And if you notice, grep original was flagged executable. This new grep is not flagged executable. So 1755, the other is 644. The MD5 has changed. Well, certainly. Let's MD5 sum bin grep star. Indeed, there's a discrepancy between the MD5 strings of these two items, as expected. And then, of course, the modification time doesn't match the RPM database. So if we stat bin grep star, we'll see that the mod times are clearly different. The modification time of bin grep is 114, and of this particular item, bin grep original, is from 2010 May. So discrepancies. So this tells us that there's a problem, and one way to work around this problem is to reinstall the grep package. That's quite possible, which would reinstate the entire configuration so that it's returned to normal. So that leads us to the next mode, install. And there are other ways to verify, by the way. You can verify packages. You can verify all of the packages on your system, which will compare everything on the system and return a report regarding whether or not there are discrepancies found. So install is another mode. Install is a mode that, of course, will install packages. It doesn't upgrade, it simply installs. So if a package does not exist already, it will place the package there. And if the package does exist, then let's take a look. We'll see what happens. Well, RPM IVH will point to grep on the remote system. Let's look for the grep package, and indeed, here's the URL. So let's copy link location and to our root shell, RPM IVH. V is verbose, H prints hash marks to indicate the status of the installation. So let's RPM IVH the following URL, grep. And it notes that it's already installed. Now let's see if it's overwritten our files by rerunning the verification on bin grep and consulting the output, scrolling towards the top. Notice that it hasn't overwritten. So the installation of a package will not occur if the package already exists. So install works if package does not exist on the system, which we'll show an example of by installing Unix to DOS. So let's get the Unix to DOS URL. And we know it's not installed because it's not installed by default. And this will be a package that's installed momentarily. And then we'll get back to fixing the grep issue. So let's clear screen, Control-Shift-V to paste, and this will install Unix to DOS. And RPM query info Unix to DOS, which is the main name, should reveal that it's now installed, which means we should be able to find Unix to DOS. That's there, which leads us to another mode. That's upgrade. Now upgrade installs and or upgrades. So if a package does not exist, it will install it, and if it does, it will upgrade it. Let's try to RPM, and this is enacted with or affected with the uppercase U option, verbose hash marks, and let's get the URL for grep, which should be on the command line somewhere, and we should be able to pull that out by going into the command history, and that's Unix to DOS. Let's change this IVH to simply UVH, which is an upgrade process. Notice that it sees that the same version of the package is already installed. Let's go ahead and run the verification yet again, and this will dump quickly to stand out, and notice it still hasn't fixed the bin grep problem. That's because the package is installed, and it's the same version, so it has no need to upgrade or fix the package because it's already there. So how do we fix this problem? How do we get around it? Installing it doesn't work because it's there. Upgrading it, there's nothing to upgrade because it's already there. So how will this work? Well, we can still use the upgrade option. There's another package that we have in mind, and that's the converse of Unix to DOS, which is DOS to Unix. So let's use it anyway. But we just want to show you that because the package is there, it will not upgrade it because it's the same version. If the version were slightly higher, it would. Or if the package didn't exist, it would. But in this case, neither is the case. So let's RPM UVH. Now this package DOS to Unix currently doesn't exist. We can RPM query, try to get information about DOS to Unix, and you'll see that it doesn't exist. So that means we should be able to install it with the U option, and now the package exists. So back to fixing our original problem. That leads us to one of the other modes, and that is to be able to remove packages, which is really a subset of installation, or the converse of installation, the fifth mode, uninstallation. So uninstallation, or uninstall. Of course, this removes packages, and it's done with the E option. So one way we could fix the grep problem, providing there are no dependency issues, is to remove it. So if we RPM or try to RPM E grep, this would help us to remove the grep program, allowing us to use UVH to reinstall it. Let's try it. Now notice grep is needed, as expected, by many different things. It's an important tool, so you just can't outright remove grep. It's too important. It's too intertwined with Linux/Unix to be removed. Now there is a way with RPM to force a removal of a package by indicating no dependencies. But this is to be used with caution because it will cause, in all likelihood, things to break. If you run RPM with the help option and then search for no deps, you'll see that this is an option that can be used if you must. This will not verify package dependencies. There is also another option that may be more suitable for our scenario, and that is to simply replace the package. So we know there's a problem with grep. We're not sure what it is, and we'd like to simply reinstall it to reinstate the functionality of our system. So this is one other way to get around this problem. So RPM E will uninstall, but this checks dependencies and warns where appropriate. So back to RPM upgrade/install, for example. To fix the grep issue, if we RPM UVH with the replace packages option for grep, we should be able to get around this problem. Let's get the grep link. Let's copy link location and paste this into our notes. And this will ignore the fact that it's already installed. And let's go back to the shell and RPM UVH grep. Now grep has been reinstalled. Now notice this reads no key, so it's unable to confirm the signature. This is something we should fix, but let's first verify whether or not grep has been fixed by looking for our RPM verification option. Let's just do a history grep RPM, and that should be 506 on the list. And now if we scroll towards the top, we should see that grep has been fixed. What does that mean for the original file? Bin grep. It's still there, and it's still available for us to fix if anything. But now the package has been reinstalled, so which grep will work, which means we can remove the grep.original file. It's no longer needed. Now back to the signature issue. By default, the GPG key that's used to sign the packages have not been imported to the RPM database. So we need to import it. That's why we see the no key. So let's just note as another task, 6, import Red Hat RPM GPG key to confirm package signatures. Now this particular file is The key, that is included with the DVD build, which we have on our remote server. So if we use the RPM import option and specify the location of the key, it should work. Let's go one level up in this tree, and we should see the keys, and this is the release key. So this is the GPG key. So if we take this URL and pass it in to RPM, it should be able to import it. And let's try this out. RPM import the following GPG key. Let's echo the exit status, and we can always confirm if the key is installed using RPM and querying and displaying the key. But let's go ahead and try to fix the grep issue once more, since it's most recent in our history. And this will replace the package. And notice this time we don't see an error concerning the ability to confirm the package that's being installed, because we now have the key installed. To confirm that the key is actually in our RPM database, if we RPM query all GPG pub key for the public key asterisk, this will return whether or not the key is installed. And if you'd like to see the individual keys, use query info against the return value to dump the GPG key. So for example, RPM query info returns this key, and it gives you information about the key. So it's a GPG public key, its version, its release, the actual key, security at Red Hat, that's a summary, so on and so forth. Let's confirm the other key. It's just a front end to GPG, which we'll look at in the security section. So query info this key, and it is a longer key, and this is the release key. So release key 2. So 2 keys are on file, auxiliary key and a release key for confirming RPM signatures. It's important to import that particular key and any key for any package signer that you'd like to confirm using RPM. So we've just covered the major modes of operation of RPM. Again, RPM does not do well with respect to dependencies, perhaps due to its age, which is why the more apropos tool in this particular scenario and nowadays is Yum. So next, we'll look at the Yum environment, how to install packages, set up a repository, and so on.